Hello, I'm going to be doing the 2004 number 3 FRQ, and the problem states that an object is moving along a curve in the xy plane and has a position of xt, yt, and what's given is the dx dt, and dy dt is not given. So dx dt is 3 plus cosine t squared, and also an initial condition is given of at t is equal to 2, the object is at 1, 8. So the first part of the problem states find the x-coordinate of the position of the object at time is equal to 4. So we must add the displacement of the dx dt function to the initial condition. So we do 1 plus integral from 2 to 4 of dx dt. So for part A, we must do 1 plus integral sign of the function for x from 2 to 4, and that gets us 7.133. Part B states at time t, the value of dy dt is -7. So we have to write an equation for the line tangent to the curve at the point x2, y2. So to find the slope of the tangent line, we must find dy dx, and that is equal to dy dt over dx dt, and these dt's cancel, so we get dy dx, and we must evaluate this at t is equal to 2. So we know that dy dt at 2 is -7, and we divide that by 3 plus cosine 2 squared. Next, for part B, we must find -7 divided by 3 plus cosine of 2 squared to get a slope of -2.983. And now we must put this in equation form, so we have the initial condition, which we're going to use, and our equation is going to be y minus 8 is equal to -2.983 times x minus 1. Now for part C, the problem states find the speed of the object at time t, and to find the speed of the object, we must do dy dt squared plus dx dt squared, and then take the square root of that. So at time is equal to 2, that would be -7 squared plus 3 plus cosine of 4 squared. Next, for part C, we must do square root of 49 plus 3 plus cosine of 4 squared. And that gets us 7.383. Now for part D, the problem states for t is greater than or equal to 3, the line tangent to the curve has a slope of 2t plus 1. We must find the acceleration vector of the object at time is equal to 4. So the acceleration vector will consist of a part x and the part of y. To find the part of x, we must differentiate dx dt and evaluate that at t is equal to 4. Let's differentiate our function. 3 plus cosine x squared, 4x. And we then can find it by using this button from for x is equal to 4. That is equal to 2.303. Then for the y part, we know that dy dx is equal to 2t plus 1, and we must find y prime of t. Y prime of t is equal to dy dt, which is equal to dy dx times dx dt. Now these dx's cancel, and we just plug in, and we get 2t plus 1 times 3 plus cosine of t squared. Now we must find y double prime of t and evaluate that at 4. We must now differentiate 2x plus 1, parentheses there, times 3 plus cosine x squared. 4x, and then evaluate that at x is equal to 4. So that gives us a value of 24.814. So now our acceleration vector is the x part, 2.303, followed by 24.814. Thanks for listening, and other vector problems that you could check out involve 2011 number 1 and 2001 number 1 FRQs.